In this video we are going to discuss about the one of the most important short answer question in the first year physics chapter, gravitation. That's the most important, children. What is meant by escape velocity and derive the expression for it. This is the one of the most important question in the intermediate first year. So that's why you have to watch the video without any skip. Dear students, in my channel I am uploading all the intermediate first year physics, second year physics and MSET NEET videos. That's why you can subscribe my channel. I am sure my channel will help you to understand physics in an easy way. You must follow my channel. Okay, so without late I am going to the topic. What is meant by escape velocity? So generally what we know, escape means what? Moving away from the issues. That is what we can feel generally, escape. So but in this case, escape velocity means the minimum velocity required for a body to escape from a Earth's gravitational field. That velocity is called escape velocity. So what is escape velocity, children? Escape velocity, the minimum velocity required, the minimum velocity required for a body to escape from Earth's magnetic field or Earth's gravitational field. Earth's gravitational field is called escape velocity. Is called escape velocity. Clear, children? And the equation for escape velocity is, we are representing that V is equals to under root of 2gr. V is equals to under root of 2gr. This is the expression for escape velocity. So children, what we know, for example, you can take a magnet. In the surrounding of the magnet there is some force of attraction is there. What it is called? A magnetic field. In the same manner, around the earth also, up to some level, gravitational force is there. Clear? Around the earth, for example, here this is the earth having radius capital R, and this is the space around the earth. Clear, children? So within this boundary there is some gravitational force is there. Within this boundary some gravitational force is there because of earth. If you want to project any body from earth surface, we are giving some velocity. Due to that velocity, the body can move away from the gravitational field. Here, what is gravitational field? The space around the earth, which is in its influence, is called Earth's gravitational field. While we are giving particular velocity to the body, if it is due to that velocity, the body can move away from the gravitational field. Then that velocity what we call escape velocity. Clear, children? For example, if any object is projected with speed of 11.2 km per second, that will enter into the space and that should be moves away from the gravitational field. So when the body is moving with particular this velocity, there is no possibility of having the body in the gravitational field. That particular velocity what we call escape velocity. Now we want to find out the expression for that particular escape velocity. So that is simply about the what is escape velocity. Just imagine this is the earth of radius capital R, clear. So for example, up to this height, when the body is projected and thus we goes to the up to that particular height h, clear. The object is projected from the earth with velocity ve, and thus we goes to the further height h. That is the situation. Now here we are projecting the body into the air with velocity ve, and thus we goes h height in the gravitational field, and that should be above that particular gravitational field of earth. So now here, for example, I am showing like this. This is the gravitational field, and in that particular height h is there, clear. So now in this case, when the body is moving with particular velocity ve, the body can have kinetic energy. So K is equals to what? Of mv square is the general formula. So now here what we are saying, the body is projected with velocity v. That's why what you write, kinetic energy is equals to of mv square. This is the equation number 1, children. So now here the body is here shifted to the height h. From where? S ground. So when the body is moved to the height h from the earth surface, for that the amount of work done, that is what, right? W is equals to F into S. This is the general formula. Here the amount of work done to move the body from earth surface to the height h. So for that we have to find out that one. And now here what is F? F is what? Gravitational force. When the body is lifted to the height h, this is the capital M, I am saying the mass of the earth, and small m is the mass of the body. That's why here what we write, according to universal law of gravitation, what we write, both are having the masses and they are separated with some distance, r plus h. That's why here we will write F is equals to gmm by r plus h whole square. You substitute this force in that equation. W is equals to gmm by r plus h whole square. And now here what is the distance? Here to here, what it is? R plus h. So everything we will count it from the center of the earth only. That's why this is the R and this is the h. So here what, right? W is equals to square, this one cancel, what you get? gmm by r. So this amount of work done is nothing but gravitational potential energy, gmm by r plus h. Here what is capital R? Capital R is the radius of the earth. What is small h? Height of the object. So that's why here, children, compared to radius, h is very less. That's why we can write W is equals to h is going to be neglected. Then what we write here? Simply gmm by r. So this is the gravitational potential energy. Clear, children? So this gravitational potential energy, this work done is what? Gravitational potential energy gmm by r. So when the kinetic energy of the body, this is the important condition, children, when the kinetic energy of the body is equals to the gravitational potential energy, when the kinetic energy of the body is equals to the gravitational potential energy, then only the body will move away from the earth's gravitational field. That is the condition, you have to remember. So now what, right? What is the kinetic energy? of mv square. What is the potential energy? Gmm by r. So small m is the mass of the body. Here small m also mass of the body. Then what do you have? V square is equals to, what do you have? V square is equals to gm by r. V square by, look here now, of V square is equals to, what do you know? Here gm by r it is there. Gm by r it is there. Gm by r it is there, children. Now here, from that what, right? V square is equals to 2gm by r. 2gm by r. For our convenient, I am writing like this: 2gm by r. We are multiplying the numerator and denominator with r. Then what do you get? V square is equals to 2gm by r square into r. We can write 2gm by r into r square into r again there. So here, what do you know, children? We know the relation between small g and capital G. Small g and capital G. What it is? We know that. What it is? G is equals to gm by r square. G is equals to gm by r square. Then what do you get? V square is equals to, instead of gm by r square, right? Small g. So what do you get? 2gr. 2gr. Then V is equals to what, right, children? 2gr. V is equals to under of 2gr. So children, this is the expression for escape velocity. Escape velocity. Very simple, children. You have to remember, when the body is projected with velocity v, that is must be going out of the gravitational field of earth. That particular v is what we call escape velocity. For escape velocity, one condition is there. What it is? Kinetic energy of the body must be equals to the gravitational potential energy. Gravitational potential energy. That's why here simply you are taking the condition like this: kinetic energy is of mv square and potential energy is gmm by r. So here small m is the mass of the body. Mass cancel. Then what do you get? Of e square is equals to gm by r. Clear? So again same thing. We are multiplying the numerator denominator with r. Then what do you get? 2gm by r square into r. We will get gm by r square will is small g, and v square is equals to 2gr, and v is equals to under of 2gr. So that is the expression for escape velocity, children. Now here you have to understand the relation between escape velocity and orbital velocity. Escape velocity and orbital velocity. So what we are getting? V is what? Escape velocity. That is what you have to write under of 2gr. 2gr. Then here we will write V is equals to, I am writing like this, root 2 into gr. Root gr. Here, but what we know? Root gr is equals to what? Orbital velocity. Orbital velocity. That's why V is equals to root 2 into VO. That is the relation between escape velocity and orbital velocity. So what, right, children? Escape velocity is equals to root 2 into orbital velocity. Root 2 into orbital velocity. So this is the condition for a relation between the escape velocity and orbital velocity, children. So dear students, if you can understand this one, like, share, comment the video and subscribe my channel to get the all notifications and press bell icon too also. Thank you for watching, children.